Good evening, I'm Peter Norton. Welcome back to ScheinTV. We're living in an increasingly digital world. Digital technologies continually open up new possibilities to increase efficiency, reduce errors, and enhance or even revolutionise what we were able to achieve before. And the digital world is here to stay. Dentistry is going through a digital change as well, and dentists are now at a point in time where we can either resist that change and be left behind, or we can begin exploring the new options that digital dentistry offers us and our patients. But how do we start? This evening, we're joined by Dr. Kasen Somana, who will talk us through his journey into digital dentistry, how we can get involved in these exciting technologies, and how the digital world has been a key ingredient to his professional success. Kasen, thanks for joining us.
Thank you, Peter. Nice to be here.
Kasen obtained his Bachelor of Science with Honours from the University of Melbourne in 1997, a Bachelor of Dental Surgery with Honours from the University of Sydney in 2003, and a Masters of Science in Aesthetic Dentistry from King's College London in 2015. He's completed advanced postgraduate education in California, Scottsdale and Miami, and is the owner of Signature Dentistry in Toorak. Our event this evening is scheduled to run for approximately 1 hour. As always, we invite you to join the conversation by using either your smartphone or Facebook Live. If you're watching us on Facebook Live, we will only see your questions and comments if you submit them via the Henry Schein Facebook page. So if you're watching us on any other Facebook page, now's the time to switch over. By joining us, you're eligible to claim 1 hour of scientific CPD. We'll let you know at the end of the event how to claim your CPD certificate. Kasen, we hear a lot about 3D printers and digital dentistry in general, but many of us, for me particularly, I don't know where to start. How did you first get involved and launch yourself into digital dentistry?
I think it's been a long process, much like you probably have been, watching on the sidelines, looking, wondering, questioning, thinking, is this the quality? Because we've all seen the research that's out there, questioning marginal integrity, scan accuracy. But in the last 5 to 10 years, it's really changed. So I was watching closely. I started to get involved in the scanning side of things, then in-house manufacturing. So the natural progression from that was to look at what's next. As I got involved with implant dentistry, the simplest thing nowadays with CBCT scanning and implant positioning was to create a surgical guide. So when we looked at the surgical guide sort of manufacturing and the cost involved in it and turnaround times.
Oh, that could be huge and
inconceivable. Incredibly inconvenient. And I'm kind of a guy that sort of would, real life example, I have a case that will be due on next week, Monday or something, or Friday. I'll design it, work out, okay, this is where I want to place the implant, everything's set, and then the night before or the morning off, I'd look at it and go, I wish I could change that. I'm going to change that a little bit more, or that position, and I'm not stressed about it because I can print out a surgical guide in 45 minutes. So that makes it easier, cost efficient, and there's no stress about wondering, is it going to arrive on time from the lab? Are there going to be problems? Is it going to fit well or not? It's just done on the spot.
Nice one.
Yeah. So that was my introduction into it. I guess the questions that I posed to myself was that what are the printers available out there? What are the different types? And what's suitable for a general practice or even a specialist practice that was user-friendly, easy to sort of plug and play, get your staff involved in it, that could take the workload off myself as well.
And preferably, as a practice owner, something that's relatively economical to buy and to run.
Correct, yeah. So in the spectrum of 3D printing, you've got anything that starts around about $300 up to $500,000. So what's the sweet spot to get the best results at a cost-effective price point? And that's when I started looking at the Form 2 from Formlabs, because it is probably now one of the number 1 or 2 sort of 3D printers available for dentists especially, and it works really well. So when I went through the process, we looked at what are the types of printers available, and really the 3 major ones are what they call the SLA, DLP and FDM.
And all that sounds terrifying to someone who doesn't know anything about it.
Correct, and indeed it was. So the SLA basically is what they call the original stereolithography apparatus. DLP is much like a projector, so you're projecting an image. so digital light processing. FDM is fused, basically, so it's the standard one which we've all seen where the nozzle injects out the extruded heated resin and to create a model. So I sort of looked at all three. The FDM didn't really appeal. Initially it was, I think 4 years ago, there were a lot of people talking about a UK company that came out with a product that was heading into the dental space, being very cost effective, around about, I think, $1,200. But accuracy, biocompatibility of the materials was a concern. So that posed a problem, and so people started shifting their attention to DLP and SLA. Major difference of DLP and SLA really is speed. DLP, which I'll show you some slides later, is faster, and SLA is slower, but in terms of quality and resolution for what we require, they're both kind of on par. We don't really need anything more than that.
And is there a substantial cost difference between those different printer types?
Correct. The FDM is the cheapest. The SLA and DLP are the more pricier options. And you can get sort of them on par. But at this point in time, I think SLA is where the sweet spot is.
So what can you tell us? I mean, you have extra information to give us about how SLA printers work, is that right? Yes.
So let's have a look at a couple of the slides. So essentially, if we have a look at this one, this is the Formlabs SLA. And essentially, you've got a model, which the software will look at it, and it'll break it down into slices. So it cuts it into fine slices. The SLA then sends out a laser that will trace a layer down onto a liquid resin, and that hardens it. Once that hardens, it then will trace the next layer. And so that resolution can be between 100 microns down to 25 microns. Do we need 25 microns? Probably not. For most instances, for practical purposes, so 100 microns is sufficient for us. So it just builds it upon layer upon layer upon layer.
And backs up. So
yes, so okay. It stacks. So it starts from the base and just moves up, and each layer is added to it. All right. So it's tracing out a pattern. All right. Versus the projector, which is the DLP styles, it's basically a projector as the same thing with the layer, as opposed to tracing a pattern. It's sending an image of the entire pattern, right, layer upon layer, and hence that's why it is faster.
So it's almost like a CT scan, or sort of like cure. Okay.
Correct. Yeah, and then builds it up, and that's why it's quicker. All right. So, in terms of usability, I think this is where, for me, Formlabs was a little bit easier. It just works a little bit simpler, and we'll come into that in a bit. In terms of the two differences, if you look at this slide, you've got the SLA versus the DLP. SLA, because it's a laser, you can trace a line. DLP, it's broken down into pixels, which are square. So there's questions in terms of how smooth things can be and the resolution of that. But like I said, practically for us in dentistry, in the in-house sort of spectrum, not really that important. This is just another slide. And this, for the FDM type of thing, this is what we've all seen. We've seen it with kids' toys. In the National Geographic store, we see these type of printers. They're great for sort of hobbyists, but not really for clinical use.
So we don't really need to concern ourselves too much in a dental setting at this stage?
No. Yeah. So I think really it's probably the SLA type or DLP of the two.
So talking about SLA and DLP, is there a difference in print quality that we can expect?
Yes, there is. So if we have a look at this, so this is FDM on the side, which we talked about, and it versus SLA. You can see the smoothness of the product here and the resolution quality. And then if a comparison between SLA and DLP, this is quite marginal, I would say. All right. And for our practical purposes, I don't see any major benefit. Right? Unless you're really pressed on time, maybe DLP is better, but I don't think we're that pressed on time for that.
And so, I mean, the unit next to you is, it's a Form 2 by Formlabs, is that correct?
Correct. It's a Form 2 by Formlabs. This is their third release material. It's very user-friendly, and that's the whole point. So it's plug and play. There's not too much fiddling around. So with the earlier sort of printers that came on, you had to really become a bit of a tech head to understand it well. You had to tweak things yourself, whereas a lot of that has been taken out. They've just created a unit that we could just literally plug and play. In terms of learning curve of understanding how to use it, I think an hour with someone to show you what's going on, how to plug and use the system. It's pretty straightforward. In fact, we could probably teach you tonight. That's how simple it is.
All right. I mean, we will be doing a demonstration in parts later on, but no, that sounds good. If you move on to the next slide, there's all the lattice work and the ballerina. I've only recently worked out that lattice work is not part of the printer. I spent a long time thinking, like, where do I put the study model, or because I was obviously barking up the wrong tree. That's essentially something that has been printed by the printer. Is that correct?
Yeah. So one of the, well, we probably should back that up a little bit in terms of the misconceptions, is that people think, well, I've got a scanner, I'm going to scan the teeth or the dentition, and then from that I can straight away print a model. And the issue we have here is that the scanner doesn't create a model, it creates a shell of the 3D image, and then we've got to create a solid model from that, and then send that to the printer.
Is that a difficult thing to do?
Not particularly. I think it can be daunting initially, because you're using software that's freely available, such as Mesh Mixer, and that's what I use. But I do it very simply, and it takes probably a minute or two to really work out. And I don't fuss about making it too neat, because I don't need it that neat. I just need a study model. So that's the benefit of it. In terms of, I think we probably should look at it. When I was looking at all of this, there's a cost investment in this. What was the difference between having the printer versus taking impression analog, what we call analog, which is impression plaster models. I like the fact that I didn't have to grind the models anymore. You don't need to have a wet grinder, plaster bay, plaster traps, cleaning all of that out. We've just basically got our printer. We design everything, try and keep it as neat as possible. That just makes the stream and the workflow a lot easier.
If you've just joined us and you'd like to contribute a question or contribute a comment or ask a question, you can do that by using your smartphone. Take out your smartphone and open the browser on your smartphone and go to Schein.tv. If you're watching us on Facebook Live, you can use that to submit your questions as well, but you can only do that if you're watching us on the Henry Schein Facebook page. So you've talked about not needing to have plaster and whatnot, but in the same way that there are different types of dental stone for different jobs, are there different types of resin for different applications here?
Correct. Formlabs has quite a vast variety of resins, right? From a dental perspective, they've got things that are specific for us, and that's great. So they've got a surgical resin, a resin for occlusal splints, model resin for if you designing a crown, for instance, or printing out the prep, and just a standard white. For my purposes, I sort of stick to I try to keep it as basic as possible. So I stock a white resin for my models, for study models, because that's just simple. It's easy. The LT resin, which is for the splints, and the surgical resin for surgical guides.
And the different resins, is that a messy situation to load them into the machine?
No, very straightforward, and we'll probably go through that later today. It's neat. I think the only thing that you've got to remember is that there's a tank for the resin in which the print is formed, and you just have one dedicated for each resin type. So if you've got 3 types of resin, then 3 separate tanks for that.
Okay, so the different resin types then, can you talk us through what they are and why we would use them?
Okay, and we're going to switch this. Okay, so if we go to one of our slides here, this is the dental model resin, all right? So this is this is built for accuracy, all right? There are all the different types of resin materials out there, different types of printers. The Formlabs system is also an open system, so you don't have to use their resins, you can use other resins, but it's ideally sort of geared up to use their resins. So the issue is with composites, we know there's shrinkage, all right? So it's the same issue with these resins that we print on. So they printed, they then have to be washed and cured, and during that curing process there's heat, which will cause some contraction. So the resins have been ideally sort of matched to get the best accuracy through that printing process, the washing process, and the curing process. And for the new sort of person in this, what does all of that mean? You print out a model, it comes out wet and hard, but it's got all this uncured resin on it, so you've got to wash that off. And that's where I think Form 2 have got a nice workflow, because then they've got a washing unit, which we then take it into, put in that bath for a predetermined time, because each particular resin has a different wash time. You wash that out, Then once that's washed, you then put it in a UV curing bath, oven, I call it, for a predetermined time as well. And that's at different temperatures, different setting times. And then once that's done, you know that you've followed the entire protocol, you've got the best out of that particular resin.
Can you give us a range for those times in terms of the wash time and the UV
Yep,
curing
so
times?
the surgical and the LT resin is usually about 5 minutes in the wash time, and that's washed in a bath of IPA, so isopropyl alcohol, at 96% and higher value, right? The white resin could be, 15 minutes or 20 minutes, depending on what the model's like. And then the curing time depends on the temperature. So the LT resin will be 20 minutes at 80 degrees Celsius. So the unit itself will heat up to that degree of temperature, and then once it's reached it, it'll start and the timer will count down. And the beauty of all of this, it can be done overnight. So you can start everything, go home, come back tomorrow, and it's all done. Yeah.
And some of the resins that are available are so-called biocompatible. What does that mean?
Okay, so the biocompatibility is important because we're using this in the mouth, right, with the surgical guide or the occlusal splints. The surgical guide one is a medical class 1 device, so it means it's a low problem or a low concern in the mouth, and the splint is a class 2A device. And this is an international standard. The class 2A being a low to moderate, so it's in other words saying that it's been tested, it's safe to be used in the mouth, and patients don't have to worry about any health risks with that. So I think this is where Formlabs have stood and sort of stand above the rest, is that they've gone and get in the US FDA approval, but also international standards.
We've had a question, what can I make and what can I not make using this type of printer?
Okay. It really depends on what you want out of the printer, right, and what your expectations are. So for me, I use it for study models, diagnostic wax-ups, for occlusal splint designs. I do my whitening bleach trays models on that.
I think we have an example of some of those, don't we? If we can move it over to our rover camera.
So this is a standard study model looking at some diastomers. Can we see that clearly? There we are. It doesn't help when it's white on white, does it? Maybe there. Okay. And then you can digitally do a diagnostic wax up and print that out, and I've got that here. And you can see the difference in that.
And is that digital diagnostic wax up a time-consuming process?
You can do it yourself, or you can send this off to your lab, right? And then they can do that. So depending on the software system you have, you can scan, you can send that off, and then there's a variety of different smile design sort of studio things out there now that you can use to help sort of transfer that information to the lab technician, and then they can use that to fabricate something. I'm sort of half and half. I believe you do it all digital, or you can do a bit of both. So you can print it out, wax it up manually. Sometimes I'll wax up myself because I just think the hand sometimes just gives you a little bit more of a finesse, and I like that. So once I've got that, I can then make a putty key and try that in, or I can rescan it, print it out if I need it.
So before we move on to other things that you can make, an extra question here is, can we make temporary bridges or crowns?
Short answer is probably not. It's time consuming, right? So for instance, a mandibular arch or a maxillary arch, it will take about 45 minutes to 120 minutes to manufacture. In practice, I don't think we have that long to make a temporary crown. Plus, there's the processing times as well. So we're not quite there yet. Will we be there? More than likely. I think there will be a revolution in material science coming forward, or going forward, which would probably be there. I mean, I've seen people talking about printing zirconia crowns before sintering. So there's people pushing the boundaries in that.
That would be a big step.
So I think there's a huge thing that's about to come. There's a revolution on the material side, on the digital, and digital's pushing that. So in the short term, I'd say the answer is no, but long term, yeah, possible.
And would you ever print something like an orthodontic retainer?
You can. There are different materials. Formlabs don't use one, but there are other companies that make those materials, which you can use in the form printer, yeah, as well.
But if you didn't want to necessarily print the retainer, presumably you could 3D print the model and then...
Do a suck down?
Yes.
Correct, yeah. Yeah. And that's the simplest way of doing it.
Is that your preferred method usually?
Yeah. I think that's the easiest way to do it, and it's the quickest. We all, in most practice, will have either a pressure forming unit or a vacuum forming unit, so you still got the infrastructure for it without too much worry.
All right. So are dentures a thing yet?
It's coming, right? Formlabs are releasing a 3D printed denture material. I would say it's probably not going to be to the standard that we accept today from an aesthetic point of view, but it's the first iteration, and this will improve as time goes on. I was in the US recently, and we talked about 3D or scanned dentures and manufacturing, and to see a company there that started, I think it was about 5 years ago, with their first iteration of a milled 3D denture, and what it looked like to where they are now, and that it's proprietary to them. You would not pick it as being a completely monolithic milled denture. It's just fantastic from an aesthetic point of view, structural integrity, fit point of view. I guess the only sort of things that we may have to be concerned about is that when we take an optical scan off the mouth,
exactly,
it's not a mucocompressive scan.
Yes.
Right, so that's something that we have to accommodate.
Border moulding and all the rest. So because I was going to ask if anything's been done to accommodate that, but it sounds like that might be a space to watch.
Yes, definitely a space to watch. It's an interesting point because for probably the last 10 years we've been moving away from dentures, and all of a sudden we seem to be wanting to go back to it. So, where do we stand with this? Is this just a fad? I don't know.
I guess we like to have options if we can. So the flexible materials, so things like whitening trays and sports mouth guards, can we do them at the moment?
No. Right. So a lot of people think, I can do everything with it, and you can't. So I'd say we do the same thing: take the scan, create the model, and then you make your suck down retainer or your pressure form mouth guard onto that model, and that's relatively simple. I think the simplicity for me is that it's just not having that plaster trimming available. You don't need to have that anymore. You do all the trimming on the CAD software, and then off you go and manufacture from there.
Well, the same questioner who asked about making temporary crowns or bridges has suggested possibly making a shell that can be relined.
You can. In terms of the materials, I have not seen any on Formlabs that I've looked at, to be honest with you. I think there are people talking about that, but is there any real benefit from a time-saving point of view, cost-saving point of view, of doing, like the wax up here, making a shell from your usual temporary crown and bridge material, and then relining that in the mouth? Yeah, it's questionable. And if you want to do it, yeah, by all means. But practically, yeah, I think it's going to be up to the individual.
Okay. A question as well about how long each print job takes.
Okay. Depends how much you're loading on, right? So, if you're putting on just one arch, that's not going to be too long. That's going to be generally, I'd say on average, anywhere between an hour to hour 20 minutes. But if you're doing several, then I'd say it's going to take about 3 hours to 4 hours. It's also dependent on the material that you're using. So, some materials cure faster, some slower. So I think that those are the two things to be aware of. This is not a fast process.
No. How does that fit into your working day?
Quite easily. You sort of, it's an interesting thing. I guess the elephant in the room is people sort of say, it's slow. And I was one of those people. Yes, it is slow. But there are so many other benefits of it, right? So I like the fact that it's clean. There's no mess up. There's storage is easy because you store the file. You don't need to store the model. So for my workflow with Scan, we would then pass that on to someone else, one of the staff members, to design the rest of it, and then manufacture overnight. So we'll wait towards the end of the day. We're not going to have any other models to go. Everything's loaded onto the machine. It's very straightforward from your computer. You can monitor this from home. So I get a text message when the printer starts, and then I get a text message from when the printer's finished. So, do
you get a text message if, heaven forbid, something doesn't go to plan?
Something's not right. You can log in. So because the printer has internet capability, either Wi-Fi or Ethernet, you can log into your platform on Formlabs website, which is only for yours, and then you can see what's going on. If there's an error, the message will come up there and you know what's going on. So you're always aware of what's happening with it. I'm not particularly interested in being connected to everything all the time, but it's there if you need it.
Well, there's a difference, I believe, between the tanks and the cartridges. Can you talk us through what those two words mean in this sense?
All right, so if we go to the slide here, which is showing the dental model, so you can see the model, and then this block on the left, that's the cartridge, that's your resin cartridge, right? And we've got different types of different resin. We've got the surgical guide one, which is the dental SG, and this is that class 1 biocompatible. This is autoclavable. Right, so it's completely sterile once you've manufactured it and inserted your stainless steel sleeve in there, and so that's what your cartridge would be. So it's all very neat and clean in that regard. This is a surgical guide. We'll come back to that later. So that's your cartridge. All right, your tank is the where the resin flows into for the print material.
From the cartridge.
From the cartridge. Formlabs have 2 tanks. There's a standard and a long term, which is what they call the LT. Recognizable because one's orange, one's green. Okay, the orange is the sort of the standard tank. For our practice or for a dental practice, I don't see any real value in having one of those. Right, they're slightly cheaper. Marginal, $20 or $40, I think the difference is. I think Henry Schein will correct me very quickly if it's not. But the difference is the longevity and storage. All right, so on the regular tank, you can print what they say up to 3,000 layers. So when you print a model, it's breaking that 3D that object into layers to print. So one, like for instance, mandibular arch will be maybe 300 layers. So you get 3,000 layers before that tank starts to degrade, and the quality and the accuracy of the print diminishes. With the LT tank, you can get up to 30,000 layers. The difference is also storage, so that you can, with the short-term tank or the orange tank, you can't store the material in there for too long before it starts to degrade, whereas with the long-term, you can store it for up to 6 months.
And the thing that's degrading, is that the tank that's degrading or the material?
Both.
Okay. Yeah. I mean, there's a unit on your right-hand side. Are you able to show us by pointing?
Yeah. We can take a walk over there if you want.
Sure. I can't because of wiring, but
actually, I'm wired as well, so I'll try and get over there. Let's have a look. So this part here is our cartridge, right? So this is pretty easy. You can train anyone to take this cartridge and put it in, and that contains the resin. It's got a little lid up the top to allow venting, to allow the resin to flow through into the tank, which is sitting here. This is the orange tank, so this is the short-term tank, right? It's got a wiper, which is unique to Formlabs, so after each layer is cured, the wiper wipes over the top, so you get a fresh layer of resin on there before it cures the next one. The actual print is stuck onto this, which is the build platform. Okay, so this moves down into the resin, sits in there, and the laser then prints onto that.
It kind of prints upside down.
Correct, and it's stuck onto that. So when you finish printing, the simplicity is you just lift this lever up. This is interesting. I've never done it backwards, and you pull this out. From there, you've got your printed model stuck onto that. And I'm going to try and do this from here.
This is really like a cooking show, isn't it? Doing everything backwards.
And you basically just let this sit on here like that. Okay. Once that's sitting on there, hit it back. It'll go down. It'll bathe for the predetermined time. Once it's finished, the benefit I like about this is that you've got wet resin on this when you take it out. When you come out of the bath, it's all cleaned up. So I would always tip it this way. So if any IPA is still there, it leaks down and not over your desktop. Then take it out, flick off the print. I just wipe this down to keep it clean because I'm a bit of a neat freak when it comes to these things. Put this back in the printer and then shut this down. Then I'll take the print from here into the UV curing bath, which is on your side. So this unit rotates, so it's got a turntable down the bottom, and then UV lights, curing lights around.
All right. Well, as part of this evening, we're sort of going through a bit of a demonstration. Obviously, we don't have the potential to sort of do the whole thing absolutely live because of the times taken for printing and all the rest. But a few days ago, I had an optical scan or a digital scan of my own teeth. I think we have some footage of that. So are you happy to talk us through
Yeah, sure.
from your perspective?
Yes, let's have a look. So here's an OptraGuard that we're placing in. And this is just to help to keep the soft tissues, cheeks, lips out of the way, right? So it just makes it easier for a faster scan.
And for anyone wondering, that is not Kasen in the footage. He hasn't had some radical surgery.
Thanks for pointing that out.
So my point there, sorry, besides that, is to point out that this is a dental staff member doing the scan for me.
So you can train any one of your staff members to do this. It's very straightforward. This, of course, is using the Trios cart, I believe, and we're scanning through here. And the key thing is to try and capture as much detail around the teeth as possible. The soft tissue, depending on what you need it for, yes. But as you can see, you're just filling in the gaps. And pretty straightforward and pretty quick.
In the spirit of transparency, I think there are parts of this footage that have been sped up just so we're not, wasting viewers' time.
Mm-hmm. And I
but
think
the clock itself is still accurate.
Correct. And I think the best part of this is that you get to sort of fix up areas that you may miss. The other thing that you'll notice when you do take a scan and you print these models, that you don't get drags, you don't have these horrible bubbles in the wrong places. And we've all seen that when we've done a bleach tray or got someone else to take an impression for a bleach tray and you look at it and you think, oh, okay, how are we going to work with that? That doesn't occur.
I did notice that because this is the first time I've had an optical scan of my own mouth. Mm-hmm. The fact that when the lady who was doing it for me just, she could just touch up areas, and that's just not possible with an analog impression, especially if you've got someone gagging all over the place. Mm-hmm. So I was really impressed by the process.
I think that the other surprising thing was that I was always concerned about the size of the scanner heads. I mean, there are multiple companies now doing this with varying sizes of scanner heads, but it's surprisingly comfortable. I don't know, did you find that yourself?
I found it was fine. I mean, I had to keep my mouth open, but that's part of dentistry. So, what are you going to do?
Yeah.
On that note, would it be possible to do a scan whilst using a bite block?
Difficult. It's dependent on the scan protocol of the unit that you're using. So every manufacturer has a different protocol. I can speak in detail of this one. Its protocol is to scan the entire occlusal surface first, then go to your non-supporting area, cusp areas, and then to the supporting.
So having a bite block in the way would be prohibitive.
Also, the bite blocks, I don't know, in your experience, tend to always push the tongue in an area that you don't want it. So no, I'd say avoid it if you can.
So once the scan has been done, we're doing a bite registration now, but the data was sent to your computer, I believe, is that right?
Yeah, it was sent to me, and then we decided to manufacture a occlusal splint for you. So we did that. So I guess what we should do, because one of the number one question we kind of get asked is, how do we create from a shell, a scan model, a solid model, right? So maybe we can have a quick look at.
If you can take us through, that'd be great, because we hear all these terms without actually getting a chance to see what they mean.
Okay, so
we have had a question though about we'll get to that. It was about sending prints to the printer. Do you have to use a certain software? But that will come later. So we'll focus on this first.
All right. So this is Mesh Mixer. This is a free software available online, and so it's easy to use. It is confronting and daunting at the same time because there's a million features on this, right? And you can go on YouTube and see how other people do it, and you could be there for 15 minutes or 20 minutes to create a solid model. I tend not to do that. I just do a very basic solid model. So, for instance, I've got you here. I'm going to open that up now. So let's look at your upper jaw. So when you've taken your scan, you export or you save that as an STL file, all right? Which is basically a 3D file, which is universal. Any system can view that.
And STL is a file type?
File type, yes. Like an MP3 or a JPEG, which we're all familiar with nowadays, right? So that's what we've done. So for instance, I'll just take that, drop and drag into Mesh Mixer. And I apologize, my computer is hooked up like no tomorrow here, so it may be a bit slower than usual. So just expect that. So it'll pop it onto the into the software, and you can see how it all looks here. Okay, and you can see it's hollow, and this is just a real shell. There's nothing to it. So if you're trying to print this, it will not print. All right. So essentially from there, I just go to Edit and Transform, right, which gives me this feature. And what I'm doing here is basically just orientating it in a horizontal fashion, and then I'm just going to bring it up above the floor there. Okay, and you can sort of level that out a little bit more if you like, and that's fine. The key thing to note now is that on the scan, I would generally, and this is all preparation, like anything else we do, we try to make sure that the step we've done beforehand is done properly, because it makes this next step a lot easier. So I would have preferred just to be a little bit more neater. I don't know if you can see my mouse there. Can we see that? Yep. So just to be a little bit more consistent and neat on the cleanup, right? And that way,
that's done immediately after the scan before it's
before it's saved.
Yes.
Okay. So let's pretend that we've done that, right? So that's taken probably 15 seconds to do this part. So then I just basically select all, which on a Mac is Command A, and this will all go orange. Then I'll just go to Edit and Extrude. Okay. And it's going to come up with this. And we want to go into the Y direction. So if you remember our good old mathematics, X, Y, and Z planes.
Takes us back.
Yes, we're looking at that. And the end type is just going to be flat.
Is this software available on PC as well?
Correct, yeah. And that's the benefit of it. You can do it anywhere. So then once I've done that, I just use this offset to move this. And typically you want to go around about, 10 millimeters. I've gone 12. Doesn't matter, we're going to see it for purposes, and then just accept. And then now that will convert that into a solid base.
So you've essentially just filled in the shell.
Correct, yeah. Okay. And that's what it's looking like there. All right. It's colored differently, but that's a full model there. Okay. And then from that, I will just go export and save it as a file. All right. So that's the study model made up, and then we can go from there and print that across into the Formlabs printer, which we'll show with the splint. I think might be the easiest. Right, does that make sense?
It does, but that's probably a good chance to go into Nicole's question. How do you send prints to the printer? Do you have to buy software?
No, the printer comes with its own printing software called Preform, and they regularly update that. And when you do buy the printer, I think you should always it'll tell you, look for updates, update everything. So update the software, the firmware on the actual printer, so you get the best results. One of the things with all of this sort of cutting edge technology, although it's been around for a while, it's still cutting edge, is that they're developing and realizing changes that they can improve on and tweak. And as soon as that's been tested, it's pushed out. And so as an end user, we want to try and get the best off that.
Yes, and I mean, it's in the manufacturer's interest as well to be making sure that their users are getting the best user experience. So
correct, yeah.
I guess everyone wins.
Yes.
What's the next step?
Okay, so the next step, so this is to creating from a scan to a study model, and that's what we do here, okay, on Mesh Mixer. So I think that makes sense. I reckon, how long did that take? Probably less than a minute?
Well, with me and you, yeah, about that.
Yeah, okay, so it's pretty straightforward. We don't need to spend too much time on that. All right, so then let's look at the occlusal splint. All right, so I'm going to switch to that. So in this particular software, this is a 3Shape software, what I've done is created a study model. The software will create this orthodontic model for you. That doesn't take too long, but because of time, I'm just going to skip that. It then puts us into an articulator, which it has done here. All right, and I've opened the bite up by 8 millimeters on here, and that's why it's open. Okay. From that point, I then just go next. That's fine. I've defined the occlusal plane. So if I just close that, you can see that in the articulator and the occlusal plane set. All right. It'll then ask me to remove undercuts. So you sort of set your path of insertion. In this case, I just did a default and said, let's remove all the undercuts. And one of the interesting things, Peter, I think as we spoke about with occlusal splints, the amount of issues we have with manufacturing of these things. I think it depends who you get
Yes.
that manufactures it. And I think we've both had those occasions where you've got it and you spent the next 20 minutes to 40 minutes grinding it back in and cursing every minute off it, saying, why?
With the patient losing confidence, like with every second, because obviously this dentist doesn't know what he's doing.
Yes.
This doesn't fit.
Yes, and you've got acrylic flying everywhere. They look like they've got severe dandruff or they've been snorting cocaine the wrong way. And I think that's why I like this, because I've got control. In fact, this was one of the major decisions, or was a point in time that I decided I needed to get a printer, was when I had a patient come in for an occlusal splint and the occlusion was just off, and she was just looking at me going, Kasen, can you just please make this yourself? And I sat there and I said, you know what, I can't argue that point. I am going to do it myself. And that's when the motion came, or set the motion to get the 3D printer. All right, so now we've got back onto the screen. It's blocked out the undercuts, which we can see there in pink. You can change this and add to it and remove stuff if you want to. By default, I'm quite happy. Go next. It creates a model with the undercuts all blocked out, as you can see here. And all I've done now is defined, I'm going to zoom in a little bit, where I want the occlusal splint to sit, right? So the borders of the occlusal splint. It will now, I should also say around this area, the thickness. Now this is important because Formlabs with the occlusal splint, like the walls, the axial walls to be 1 millimeter and the occlusal to be 1.5. I by default just set it at 2 millimeters and I'm happy. The other thing is an offset. They say 0.1 of a millimeter, so you just plug that in there and that's enough. And
so by offset, what does that mean?
It's just the offset of the where it's placing it. So it's just 0.1. You can go down to, depending on if you mill a splint, you can go to 0.01.
So essentially how intimately it's going to fit the tissues.
And how much it sits out, So what it does next on this image here, we'll see it just creates a uniform 2 millimeter thickness, right? So I guess in our terms, we would say that this is like a suck down, a hard acrylic suck down made on the model, and that's fine. I don't tend to fuss around too much with that. Then asked me to sort of define a spline. And really the simplest way to describe this is the area that you want to have your occlusal wear plate. So if you're creating a platform for the wear, right? So you just define that across the top, and that's what I've done there. It then creates a bar for that, and then you can alter this just by moving things up and down, left and right for the thickness. And the important thing to do here is just sort of see, I'll get rid of how that fits over the top. Okay, I don't spend too much time with this trying to make it absolutely smooth, because it's just, as long as it's close enough, that's fine, because I can trim this off with an acrylic burr later on, right? So then we go next. I never fuss with that. Next stage to modify anything, I'm quite happy with that. And then we go to combine the models. So now what it's doing is taking that shell, which is 2 millimeters thick uniform, and that bar and fusing it as one. Right. This may take time given my processing speed on my PC, but let's see how we go with this. And this is, I think the next part to this is the interesting part, because now you're going to have control over the occlusion, right? Because it's going to put you in a virtual articulator, and essentially what I do is grind in the occlusion to try and get as a uniform occlusal contact across. So you'll see that in a moment, and that's where it will control it. And in fact, we did that with you. So we'll get to see what you think about it. So here we are now.
Before we carry on though, you've just been talking about two separate things. You're not going to print a study model and print a splint. The study model was really just to sort of say, look, this is how it's done. Now we're going to make a splint, but there's no need to print a study model beforehand.
Correct. Yeah, sorry. Yeah, we should have probably prefaced that. So the reason why I was showing how to make the solid model is that if you want to make this, we can through Mesh Mixer. Very straightforward, doesn't cost you anything, and it's simple, and it only takes a minute to do so. A lot of people get frustrated with it. I've sort of been at lectures where people say, oh, do I have to use Mesh Mixer? It seems so complicated. And when you look at it, it does look complicated. But as you can see, just doing just 3 things that I did, you can come up with a solid model quite easily and quickly, right? But when you're doing the split, you can do this completely model-less. And that's what we did. for yourself, and even I did that for myself as well. Okay, so here we are with the articulator in place and the splint designed. I'm just going to remove the articulator and I'm going to remove the lower model. So with this, now it's got everything in there, and all I'm going to do is just get the model to and the articulator to show me the contacts. So I just press play and you'll see it move around, and you see the contact points come in place. Now you want to do more than that, you just go adapt the design to this, so it will then grind that off. Like, remember old dental school times, it will slowly take off the wax. It just does that digitally, and then it adapts the design. So we'll see now when we press play again, where does that sit? So you can continually do this until you find that, you know what, I'm actually comfortable with this occlusal scheme, that we're getting even contacts both bilaterally and anteriorly, and then you just go next. All right. If you
We've
want,
had a question as well. Where did you learn to do all of these?
Good question. Kind of by myself with the help of Henry Schein support as well. They've been incredibly resourceful in that regard. I think that gets lost in the picture. There's multiple times, you know, it's an interesting thing. This, and I'm going to go off on a tangent now.
Tangents are fun.
Right. So a lot of these products are available from different vendors, right? And people say, well, you know, I can save $500 going to this vendor, or save $1,000 going to here. And there's nothing wrong with that. I think that's great. Save some money where you can. The issue, what costs money for me, is time when problems happen and who has the resources to resolve them quickly. And so for me, yes, I look at Henry Schein and think, okay, sometimes it's much cheaper than the others, and sometimes it's a little bit more expensive. But they've just got the resources to help when things are wrong, right? So for instance, if I've run out of resin, I can call up and know that it'll be delivered the next day. Sometimes it's fast, and I'm surprised at how quick it's come. And I'm like, wow, that was amazing.
Were you hiding around the corner? Yes.
Yeah, you know, and I think that is really helpful, and knowing where things are in the supply chain and what's going on. So I think that's really important to understand, that you need that backup and that training support, that you can call someone and say, hey, I need some help. Can you dial in and show me what I'm doing wrong here? Right? And so that's what I did. I experimented. I'm probably a little bit OCD with these things. I'd go on YouTube and say, okay, what are they doing there? Look at that, and then modify it to what I want to do. Right. So, for instance, for the splint design, I did go on YouTube as well. I found it interesting, but I found it was a lot of fiddling around, and too much time was being spent when I could just say, well, you know, I'll get it close enough, and my acrylic bursts faster. All right, and then I'll fix that up afterwards, and that's what I've done.
Well, it is about efficiency. So before we carry on to the next steps, I mean, would you mind just recapping just broadly the steps so far?
Okay, so what we did was we imported from the scan. We imported your scan into the software. The software created an orthodontic model that typically takes about 3 to 5 minutes. It's very, very quick. All right. From that, it'll ask you to define or show you the occlusal plane, which literally takes 10 seconds. Okay. From that, it'll put it into an articulator. At that point, you adjust the articulator to the opening that you want. I will always start around about 8 millimeters. I'm not too averse of having a thicker occlusal splint. My patients are fully aware that these are not romantic devices. So it is what it is. It's there to protect the teeth. And in your case, I did yours at 8 millimeters, and we did grind that back down in to get the occlusion closer to where I wanted it to be. So that's what we set up there. We then created a 2 millimeter thickness shell of the resin to sit around, which will give us flexural strength and rigidity. Once that's set, we then create the platform for which you will be grinding on. All right, and that was that bar that they're called. Once that's done, those two models are fused together as one, and then you can modify the shape of it, smooth it over, cut it out, whatever you'd like. I generally don't. I just try and keep it simple, right? And then we come to this stage where this is now virtually articulated, and it's mimicking the jaw movements. In this particular software, you can alter that. So if you want to change bending angles, lateral intrusive records, you can do all of that. Is it necessary to do so? Probably not, because you can just do it as a generic and then make the final adjustments in the mouth without spending 40 minutes and creating a dust storm. right? So that's where we are now. All right, so once that's set and you've got the occlusal wear pattern and uniform occlusal sort of forces bilaterally and anteriorly, we then go ahead and go to the processing stage. You have the benefit here if you want to put an ID tag on it, you can. I don't bother with that. I think it's fine. We know who we're manufacturing it for. Also, when it's saved, when you send it to the preform software to print, it will create a platform like this. And Sean, if you want to come closer, it'll create a bed like this. And on this bed, on the edges, is the name of the design. Right, now you can't see it on there, but I can see it closely here. Right, and that's the key thing. So you don't need to worry about putting ID tags because it's on there. Okay, does that make sense?
It does. Yeah. So it's in really fine print on the base part of the support structure.
Yeah.
You mentioned an ID tag. Does that mean that it could print someone's name in
Correct.
the splint?
Yes.
Oh, good to know.
So you can print that in there and leave it on there. I think that would be quite irritating to the tongue, so I don't do it at all. So the next stage it will come up with, if we go back to the screen, drill compensation. I'd leave it as a default because 3D printing, you can get into undercuts. You don't want that. So drill compensation basically allows for the drill to remove the undercuts, so it just makes a very parallel walls. So I'll leave the drill compensation present, and this one's set at 0.5 millimeters, and that's sufficient for us to get a good result. It then allows you to modify the model, validate it, which we'll skip through all of this here, which might take a bit of time. But essentially, basically from this point onwards, it's going to create an STL file as an output, much like what we did with the study model, and then we'll have that on our desktop. Okay. Do you want to see this, or can we skip to the next?
Well, it's up to you to whether it's useful. But so
is this making sense to you?
It is. Yeah.
Sorry.
So the STL file is a different STL file that the printer is capable of reading as well.
Correct. Yeah. So now it's a solid model.
Okay.
Right. Whereas the initial scan of your teeth is not a solid model; it's just a shell. Right. Right. So that's what it's done there. It's created it. We just go next, and it'll ask you to do a cross section to make sure the minimum thicknesses are there. With what the setup that I've already shown you, guaranteed the thickness is there. So, and then that's it. It's created it, and it's saving the model. So that's it there. All right, all set to go. And we go to close, and that's your model there. And we just then export that file from there. Okay.
To the printer.
To the printer. So I've already got your file, and I had to play with your name, so I've called your splint Peter Norton Antivirus.
Makes perfect sense to me.
Yeah. Yeah, simple minds, I say. So I just right-click on that, and I'll open that with Preform, which is the Formlabs printing software. Okay.
We've had a question while that's happening. Can I track my prints, for example, how much longer until the job is finished?
Yeah. So Formlabs have a online platform. It's a web portal. Each printer has a unique name and it's like a serial number. So once you register with them, your printer is registered, long as it's connected to the internet, which is easy to do. And then from that, you can see from home, remotely, anywhere, what's going on, right? On that, you can tell how much resin you've got left, how much you used. So you can keep track on the whole thing. They keep that as statistics as well as to how things are performing. If there's errors, you can report back to them and report back to Henry Schein. So all of that is fed through that network. So you kind of feel very safe with this system. And that's probably one of the major reasons why I went with this versus any other one. All right. So here we are. Here it comes up. I've already got the dental LT tank in there. Apply that setting and it sets it up. Now, the important thing here to look at, I'm just going to increase the size of this. Okay, hopefully that's more visible for you guys at home. It just default puts the splint down. Now, you'll note that the splint is showing with the biting surface up, and what we want to do is actually have that the other way around. Okay, because we're going to create support structures. So I just turn that upside down.
Because otherwise the support structures would be on the intaglio, which would be very difficult to adjust, to
polish. To remove and clean and make it easier to fit, right? So we put it on the biting surface, which is easier for us to remove and clean, right? Now the key thing to note here is that with Formlabs testing, a lot of people try to say, okay, let me just do it this way and keep it horizontal. They find that you get a better result when this sits at around between 15 and 35 degrees. So something around about there, you get a better print accuracy, all right? So once it's set on that position, I then just default hit this little tab here, generate selected. And what it's going to do is now populate the support structures. So some people think you can, just print straight on the bed. You can. The benefit I find of, and that was me, by the way, thinking, well, it's quicker if I just print directly on the bed. And it is. The benefit, though, of having these support structures and that platform down the bottom is that when you're washing it, you're getting a thorough wash throughout the entire model. And then when you're curing it, the UV light's penetrating everything because it's not sitting flat on that bed, right? So I say, look, just do it this way. It's simple. And that's what I've done here. So the support structures are set, and that's what you're looking at.
And does the curing light, I mean, obviously those support structures will create some shadows. Does that have any practical significance?
No, because it's heated up and that whole entire thing is reflective. So it's going through.
And you said rotating as well?
Yeah.
Okay.
So you're covering everything. Is there one, dark recess area that's probably not hitting? Probably. Is it going to have an impact? Probably not. Yeah. So I haven't had any negative experience with that. So the main thing here now, if you look at this, is that you can position this anywhere on that build platform, which we saw earlier. You can take this and move this around. Right, so if you're doing multiple units, or if you want to print, for instance, 2 of these, you just go duplicate, and then you've got it there and you can move that. All right. So I guess on that duplication side of things, we should talk about, what is the longevity of this, and where does it match a milled splint, or does it match a handmade, powder, a liquid polymer splint manufactured? The question is, I don't think we truly know the answer to this. It's still very new. In essence, I would say, look, if we got 2 to 3 years out of this as a functional unit, great. Does it worry me that I may not get that kind of longevity? No, because I can cost effectively print another one out quickly, right? And there's some that argue, one at the same time, just print out 2, give the patient 2 as a backup. And so therefore you've got the same longevity if you're worried about it at a cost that's nominal to you. So,
well, I have a patient whose dog is obsessed with her splits. It has become an ongoing, expensive chew toy situation. So this sounds like an amazing opportunity for her.
Correct. And the benefit of this, I mean, we all know what the costs are from a laboratory standpoint to manufacture a splint. This is probably about under 1/10 to do it from a lab if you do it yourself. So I think that benefit, and I think that also switched me. I don't know if we covered it, was the other sort of decision to get an in-house printer was that from a surgical guide point of view, the cost of manufacturing a surgical guide was in the ballpark of about between $250 to $350, even up to $500 per guide. And that was getting costly. And you're sort of saying, well, I either pass that on to the patient or I absorb that cost. And then you sort of start getting into the realm of, are you in the marketplace cost-wise? All right? Are you pricing yourself out? Whereas we can design this, manufacture this in-house for a nominal fee and quickly. So when you look at that based on the cost price, and I think, quote me if I'm wrong, it's rough, if you've got the entire setup, it's around about $8,000. And on sale, you could probably get better than that. On a lease or hire purchase, that's about $155, $160 a month. So one surgical case, one splint will cover your repayment costs per month on this. So from a cost point of view, it's a no-brainer.
It does work. So is the next stage, I mean, when do we send the job to the printer?
So now once we've got that, that's it. We just, this orange button on the side, which my mouse is flicking on, you just hit send, and we just do that now, and we'll go to the printer. And if we go to, Sean, if we go to the printer, we should see that coming up on the screen. And I'm going to lean over the top here and not hurt my back. And it says print now. We hit that. It's going to say open the cartridge, which we have. And it's checking. We just confirm that we have done everything correctly, and it'll now start doing its job. So it is literally as simple as that.
And how long would an occlusal splint take to print? If you're just doing the one.
The one, okay. So
or 2.
For instance, yours took, let me just remember, I in all honesty, printed that last night. So, so I think that was about an hour, 20 minutes.
Okay. Yeah. And if you're printing 2, is that automatically double the time?
Not always exactly double. It can be a little bit, a little bit shorter. So you could probably, be, so what, 120s, what, 240s? I'd say probably 2 hours.
So judging by the support structures and all the rest, obviously the splint doesn't come out ready to go into the patient's mouth. There are a few steps in the meantime. What are those steps?
So it's going to come out stuck on the build platform upside down like that. So Sean, can you see that? Yeah. So it's going to come stuck like that. You'll then take that, put that in the wash unit. And
because it's also going to be quite gooey at the time.
Yeah, very gooey, and it's kind of stuff that you do not want to get on your clothes. Ask me how I know that. You never get it off. So you wash that out, clean it, and then this comes with a tool to flick it off the build platform. You'll take that off, and then you'll take that and pop that onto the curing platform. All right. Then that'll heat up to 80 degrees, and this will cure for 20 minutes. After that, this is ready to go. The unit comes with a set of pliers, which you just break off. So Sean, if you want to come in closer here, you've got these pliers, and you just break these off. I'd recommend wearing some goggles here because these do fly around a bit. So I will demonstrate, click that off, and it'll break away. And then once that's done, you basically come up with a unit like that, completed. And then all I do is just get an acrylic burr, just burnish the sides, any sort of sharp edges, remove any remaining support structures. If you want to, and you really, fast, you can get a high buffing burr or buffing wheel and buff this up and shine it up really well. I think we've got an example of a really shiny one here. All right. Is that essential? For me, not really. So it's just really aesthetics, which yeah. Okay.
So we've had some questions. What is the warranty on the unit?
Okay. So this once again goes back to support structures that is available to you. So Formlabs isn't locked into any one particular supplier. I think there are probably 4 or 5 in Australia. Henry Schein is one of them. With other suppliers, I think it's 12 months. With Henry Schein, you get 12 months plus an extra 12, so it's 24 months, 2 years of warranty.
All right. Yeah. And if storing your hard copy models, do you print an ID on the model or case to identify it if a remake is necessary?
I don't really store the hard copies. Once I've used, I throw them out and I just store the soft copy.
And now, do you have to change the resin tanks each time you put a new cartridge of resin?
You can't swap between resins, right? So you can't use the same tank for a different resin, right? So you've got to stick with the same one. So if you're using the LT, then you just use the LT tank and you can use that. I think it's probably wise if you've got a resin that's been sitting there for a while, tip that out and start with a new cartridge. Yeah, so I guess so I guess we probably should talk about some of the negatives, right? There's a lot of positives here. So what are the negatives? There is a bit of wastage.
Of resin?
Of resin. You're never going to squeeze every drop out to manufacture something. I have heard of people say, well, look, I've got a little bit of resin left. I'm going to try and print a toy for my kid. And, if you can, by all means do so and have some fun with it. But yeah, there is a bit of wastage with that. The resin tanks don't last forever. So, there's that lifespan of that. And then from there, the resin itself, the cartridges have a lifespan. So the biocompatible materials are, I think, 24 months, and the non-biocompatible is about 12 months. So we just got to be aware of those warranty or usages, use by dates, so I say.
Another question, and thank you for your questions. Do finished printed models need to be, or other printed products, need to be stored in light safe storage long term?
No. Yeah. It's already stable at that point. Once it's cured, it's stable.
And how many things can you print on a platform at once? And can you nest them throughout the day and then print?
Okay, so there's a few things there. Okay, how many things at once? Depends how many you can pack onto the platform, right? How big they are. I've seen images of people printing sort of orthodontic models for making clear aligners. And they're vertically stacking them and getting 20 sort of models on there. But you remember when you've got that kind of volume and density, it's going to take a long time to print. So For the average practice, I don't think you'll be printing more than 4 or 5 different models at a time. Can you then preload and set up different ones? Yeah, you can. All you'll be doing is setting it up, saving that as a file to go back in and then just click print. But you can't stack it in order. Not yet. I'm not aware of that at all.
And you mentioned, correct me if I'm wrong, that you've leased your printer.
Yeah.
Do you know if Henry Schein has finance options available for people who don't want to lease?
Yeah, I think we've all got our preferred financial person that we work with, and usually these are relationship based. So whether it be Medfin, Experian, but I think Henry Schein's got, was it Macquarie? I think it is possibly. Yeah, but they've got a system set up there.
Okay. Well, look, unfortunately, we're out of time. Before we do go, though, we'll be expecting to see this finished in about.
Oh, it should tell us on the screen there. I can't see it. There we go. 1 hour, 5 minutes.
Okay, great. So again, cooking show here. Here is the splint that was prepared for me earlier. Yeah. I'm Sean, if you can see over here. So I'm pleased to say that on trying it in, and this is not just because we're on TV, it fit really nicely. Mm-hmm. The bite might need just a small amount of adjustment, but compared with what we were talking about before, sometimes we've spent what feels like interminable hours adjusting with a patient there. Mm-hmm. This feels like it'll be really, really set to go.
Yeah,
so.
I think you probably spend 5 minutes at most to get it absolutely right.
Okay, well, Kasen, thanks. You've given us a lot to think about and a huge amount of inspiration to actually get into digital dentistry and see how it's been such a vital ingredient in your recipe for success.
Mm-hmm. Well, thank you for having me. I think for anyone thinking about it, it's a good time to get involved because it's still in its infancy. Things are changing, and 5 years from now, we've moved so much more forward that jumping in then might seem a little bit more harder. Always getting in early, understanding the basics makes it a lot easier later on. So I encourage you to think about it.
It's a good time to get on board.
Yeah.
And thank you for joining us and for your questions and comments. You can claim your CPD certificate by contacting Henry Schein. And if you have any further questions about anything we've discussed this evening, your local Henry Schein representative will be happy to help. Thanks again, and see you soon on ScheinTV.